disclose partial information about these security problems. In worst case or best case, depending how you see it, they just notify that you have a problem, please patch. Please install these corrections to get rid of it. From attacker's perspective, it makes it difficult for them to analyze how to actually create an exploit against it, but it's not impossible. For users' perspective, if they believe software developers enough, they will install the corrections anyway. If not, it's difficult for them to make their own risk assessment. Full disclosure, always with open source, means that all details are public. You can even review what was the change actually made to the source code. In some cases, reporters include an exploit also. Exploit is extremely fast available, meaning you can easily abuse those problems as well. But simplified, or not simplified, the whole process of someone finding a problem to actually resolving it includes a lot of communication. Even when you are communicating with only one software developer, maybe some coordinating organization like US CERT or some other incident response team, at minimum it usually takes tens or hundreds of emails or telephone calls to get the issue resolved. In some cases, it's thousands of emails and communications. But still, it's a process, and if it's a process, you can describe it, you can study it, you can make analysis of how it proceeds from originator's perspective, finder's perspective, coordination perspective, and repairer's perspective. Extremely interesting research topic if you are interested in this. In communication, vulnerability communication, you have lots of problems. As I mentioned, the biggest one usually is the volume of communication. Many of the people just don't want to get involved with it. Trying to convince people that you really have a bug, trying to convince them that it really is a security bug, it really is critical. Sometimes no one can reproduce what you found. Sometimes developers fix it, but you can easily find a way to actually abuse the same problem again. So it's like just looking at one line of the code, fixing the exploit actually, and not fixing the whole problem. Sometimes you are happily resolved the issue, but then suddenly notice that the same problem is in products of hundreds of other vendors. Same bugs come again in that sense that some people just copy and paste code from legacy systems. In some cases, they just branch products and fix only one branch. And worst thing usually is also that sometimes people don't want to upgrade their systems without actually having high enough risks involved. So you need to have exploits to motivate customers, motivate users to upgrading their systems. That's not a really good thing. I will conclude with few slides. Software security is software quality. So most of the problems are software quality related. Most of the problems that at least are abused out there are quality related. Every now and then someone breaks crypto, and that's nice, that's interesting as a research topic, but it's not where most of the problems are. You have to have good crypto, but when you have it, most of the problems will come from actually implementing the crypto. If you have 4 nines, 5 nines, 6 nines reliability, you still are 100% vulnerable if you have one problem there. So doing risk analysis in a system starts from analyzing, identifying all communication interfaces, critical sections within networks, and studying the openness, complexity of the interfaces, studying how much of the software itself is exposed out of these communication interfaces. Then it's a process of testing, reanalyzing, and reiterating the whole cycle again. You will never get rid of all the problems. Problems will come back. You cannot just end it in one cycle. I will end with some words from Boris Pager, who is quite famous testing engineer. In security testing, as in quality assurance in general, testing is important. Testing is extremely interesting topic of research as well. And it's really unfortunate that today, if you cannot code, you become tester. So it's not like quality attribute. Good testers are really good testers, and they are better usually at it than anyone else can be. And the better tools you have there, the more effective you can be. The more automation you have, the more effective you can be. So you can kill the interest of testing by having bad tools as well. But testing is not to cause harm to the organization, it's to help programmers. That's it. If you have any questions, I'll be happy to answer now or later on. If you want to contact me later, I can provide contact details to you.
Yes. You mentioned at the beginning of your talk common criteria. You said they didn't include metrics of software or even consideration of software quality. Is there a suggestion you could make for that?
I know of at least one common criteria certification where robustness has been taken into consideration. It's I'm not sure if it's a standard, but it's a robustness profile called addition to common criteria. So as long as you don't have standards to test against, you cannot have certification for robustness either. So there are some organizations like IETF, ITU, other bodies who are responsible for standardization of software or protocols or specifying protocols, who are actually specifying robustness tests as well. That could be one solution there. So then common criteria can verify against a set of tests that have to be implemented or have to be passed. But otherwise, if you consider specifying in common criteria that you have to have 4 hours of fuzz testing, it's not a really good criteria. Or you have to have this level of penetration testing. It's difficult to measure and difficult to certify.
Okay, so you were not referencing software quality metrics that some people generate. You were referencing robustness testing, or that would be your preference as a way to include software quality as a common criteria.
Yeah, so if you have certification, you have different criteria for certifying it. You can have conformance to a security standard, for example, torture tests by IITF. So it's a set of tests for testing robustness. You can have a set of accepted performance testing, for example, for common criteria. And you can have accepted level of penetration testing, but it requires a metric there. It can be based on standard quality assurance metrics like code coverage, branch coverage, and so on, but it has to have a metric.
Any other questions? Okay, let us thank the speaker then.